Picking up with Unit 3, Lesson 3, heading into a key concept and then heading into example 5. So our key concept here is transformations on logarithmic functions. And again, we're going to see this A out in front of the expression, which tells us the orientation, whether the graph faces up or down. And if A is greater than 1, then it's stretched out vertically. And if A is between 0 and 1, then it's compressed. We're also going to see H and K. H tells us the horizontal, K tells us the vertical translation. If we see an x minus h expression, we're going right. If we see an x plus h expression, we're going left. If we see a plus k, we're going up. If we see a minus k, we're going down. So let's apply this concept now into example 5. So we're going to graph the function 1/3 log base 6 x minus 1. So what we want to do here first, I think it would be really smart to identify the transformations on our graph. So we can see that our A value is 1/3. That means our graph is compressed vertically, which means it's squished down. H is 0. There's no x plus or minus anything in parentheses, so there's no horizontal shift. And our K value is -1. So our graph is going to be shifted down by 1 unit. So our basic graph, if we have log base 6, we would be at the point 1/6, comma -1, but we're actually shifted down 2. So at 1/6, let's draw this up here. We would have been at 1/6, -1, but since our graph is shifted down 1, we're actually down here at 1/6, -2. We would have been at 1, 0, but we're shifted down 1, so we're at -1. Or we're at 1, -1. And we would have had a point at 6, 1. Or, sorry, we would have had a point at 1/6 to -1 and then 6, 1. But our graph is shifted down, and since it's compressed, our next point is over here. So basically connecting these 3 points again, we're going to form our graph that goes out in this direction. Okay, part B, we're going to look at how to graph the function 4 times the log of base 1/3 of x plus 2. So our first thing we're going to look at is our A value, which is 4, which means our graph is stretched vertically. We have an h value of -2. Remember, this is x minus -2, so we're shifted left 2 spaces. And then there's no k value over here, so we're not shifted up or down. So the graph of log base 1/3 of x, it would have originally had a point at 1, 0. But because our graph is multiplied by 4, we are, well, first off, we're shifted left 2. So instead of at 1, 0, we're shifted left 2. So we're at -1, 0. We would have originally had a point at 1/3, comma 1. But since our graph is shifted left 2, we're down here, and then we're multiplied by 4, so we'd be up here in this general area. And we would have had a point at 3, comma -1, but we're shifted left 2, so I'm going left 2, and then multiplied by 4. See my y value here is -1. If I multiply -1 by 4, I get -4. That gives me this point down here. So connecting this point, and this point, we form this blue line. And this is obviously a little bit trickier to do by hand, but I'm always going to let you have access to a graphing calculator while you're working on this. So just make sure you grab a graphing calculator when you have to do the graphing for logarithmic functions. Okay, we have a check your progress. For part A, we need to graph 1/4 log base 4 of x minus 3. So think about the shifts, think about the stretch, think about the original base function that we would be graphing. Okay, our answer for part A is choice B. And we're going to look at part B. We have to graph 2 times the log base 1/2 of x minus 1. Okay, we're going to head on to the answer now. And our answer for this one is choice D. Okay, example 6, we have a real-world problem. It says, at Earth's surface, the air pressure is defined as 1 atmosphere. Pressure decreases by about 20% for each mile of altitude. Atmospheric pressure can be modeled by P equals 0.8 to the x power, where x measures the altitude in miles. Find the atmospheric pressure in atmospheres at an altitude of 8 miles. So clearly here, if we're finding an altitude of 8 miles, we're just going to plug in 8. So we're going to get a pressure of 0.168, about 0.168. So our answer is 0.168 atmospheres. And for part B of our equation, we're now going to write an equation for the inverse of this P equals 0.8 function. And the key here is remembering this is exponential form, and the inverse of exponential form we did back in example 1 and example 2 is the logarithmic form. So we need to take this expression P equals 0.8x and put it in logarithmic form. So in order to do that, what we need to do is flip the variables, flip the x and the p, and then that's going to tell us that p equals log base 0.8 of x. Remember, when you have an expression like this, you would take the answer here, and it goes as the log value. You take your base, and that goes in the base, and the exponent is your answer. So the key to doing this, to finding an inverse in general, is flipping your two variables and then working with going from exponential form back to logarithmic form. Okay, we're going to do check your progress. So this time we have the equation P equals 44 times 0.99 to the x power. And we're going to find the pressure in pounds per square inch after driving 350 miles. So plugging in 350 to our equation will give us an answer of B41. So we have 41 PSI, that's pounds per square inch. Okay, in part B, we're now going to take this equation and try to find the inverse of it. So remember, we're going to flip our variables, and then we're going to come up with our equation. And we see here that our answer is choice D. You might not understand why this would be x divided by 44. And if that's something you are confused about, you can either Google how log functions work, or you can ask me in class and I can explain and show the work for this in class as to how you get this example. Okay, so that's the end of Unit 3, Lesson 3. We've just finished all of examples 1 through 6. So you can exit out of this video now and get started on the classwork or the homework or whatever you need to do related to this lesson.